So all you could do that, right? Every single one of you. And you know the solution is that point because that point has an x and a y that work in both x and both y's there, correct? All right, now we're going to do some funky stuff with this. Pick a number between 1 and 10. Do not say it out loud. I lie. Pick a number between 2 and 9. Do not say it out loud. Write it down right there. Okay? So you're going to write your number right there. Number. Then you're going to multiply both sides of the second equation by that number. So the second equation was 5x minus 3y equals 27. You're going to multiply that by your number. And then you're going to isolate y. So whatever this answer is, you're going to get y equals whatever that is. Everybody understand? Go. I'm going to do the number I chose and write it out here. And when you have done all that, you will notice something. What do you see? Simplify those numbers. That is what you see. When you simplified, you got the exact same line. And that should make perfect sense to you. Because you have been seeing this property of math since the very first day that you did fractions. Because you're all aware that 1/2, if you multiply both of those by some other number, that result is still 1/2, right? So that is the first piece of knowledge to take away from this. Multiplying both sides of a linear equation results in a new equation, for the same line. So it will look different, but all the x's and y's that work in it will still be the same. Does everybody understand that? What it means is we can change the appearance of an equation. Does that change in appearance affect our results? No. Is everybody good with that little mathematical nugget of information? Yes? Spectacular. Turn the page over. Add these equations. What? That's weird, but let's do so. What is 4x plus 5x? 9x. What is 3y plus negative 3y? 0y. And what is 0 plus 27? 27. Can I graph that? Of course I can, because what does x equal? 3. So if I were to go back up to my graph and graph x equals 3, it would be this line right there, wouldn't it? Where does it go through? Goes right through my solution, doesn't it? Everybody with me? What happens? The line goes through the x coordinate of my solution. So notice what happened right here. When I added those equations, what happened to y? What happened to the y? It disappeared, or it was eliminated. Why are we trying to eliminate variables? Because we can't solve this with two unknowns. Right? Once y is eliminated, what was left? X. And we got our x, didn't we? Now let's do this. Let's subtract them. What is 4 minus 5? Negative x. What is 3 minus 3? Plus 6y. And what is 0 minus 27? Negative 27. And if we graphed that, we would get 6y equals x minus 27. Y equals 1/6 x minus 27 divided by 6 is ugly, isn't it? Ugly, right? It's 3.5. Agreed? Or 4.5, right? Could we graph that on our upwards equation or on our grid? Sure we could. We'd go to negative 4.5. 1, 2, 3, 4.5. And we'd have a slope of 1/6, correct? So I'd go up, how far? 1 to right here and out all the way to 6. 1, 2, 3, 4, 5, 6. Oh, I went to 7. And oh my good gravy, what did we just do? We went through the solution again. So, adding or subtracting two linear equations results in what? The same, doesn't it? Right? If we add or subtract linear equations, it results in a new equation. A new equation with the same solution. Everybody with me? Everybody good? Okay. So, knowing what you know now, write one more equation here. Write a third equation that will have the same solution as this system. I've given you 3 ways to do it. Everybody should be able to write one more equation here. I'll wait a moment while you think about that. You've just seen 3 ways to change the look of an equation. When you feel you are ready and you're feeling confident and you feel like taking a chance, tell me what you wrote right here. Pardon me, Gervier? 4x minus 2y minus 2y Okay, what did you do to get that? Okay. The x is correct, the y is not correct, and the constant is not correct. Y equals negative 4x plus 19. How did you get that? You added the equations and solved for y. Perfectly acceptable. Let's check and make sure. Add the equations. 3 plus 1 is 4x. That's why Gervier was right. 2 plus negative 1 is 1y, right? And 18 plus 1 equals 19. And then he solved for y. Perfectly acceptable. Does anybody have something else? Dan. Okay. 2x. Subtracted. 2 minus 1. Plus 3y. 18 minus 1. 17. Perfectly acceptable. Does anybody have something else? We've covered both methods. 2 of the 3 methods. We added them. We subtracted them. What's the third thing we could have done? Pick.
A number between 2 and 9?
Well, it didn't even need to be 2 and 9. Pick any number and multiply it. So 6. So we could have had 18x plus 12y equaled 108. Everybody cool? You can add them, you can subtract them, you can multiply them. You'll still get the same solutions. Everybody good? Now, knowing what we know, turn the page over, and just like with substitution, I give you the steps. Okay? So, step 1. We're going to add or subtract to eliminate a variable. So let's look at our 2 equations here. What variable is easily eliminated? Y. How? If I add these, they're going to disappear, aren't they? So what is 3x plus 4x? 7x. What is negative 5 plus 5? 0. And what is negative 9 plus 23? 14. That's this first step. I have eliminated my variable, yes? Step 2. Solve for the remaining variable. How do I solve this? Divide each side by what, Gio? 7. So what does x equal? 2. If x equals 2, what do we know about every x up here? It's always going to be 2. So plug in the value. Where can I plug it in? Any x I see. So could I do 3 times 2 minus 5y equals negative 9? Could I do 4 times 2 plus 5y equals 23? Yes. It doesn't matter which one I use. If I do the blue one, then I get 6 minus 5y equals negative 9. Negative 5y equals negative 15. Y equals 3. If I do the pink one, 8 plus 5y equals 23. 5y equals 15. Y equals 3. And what is my final answer? 2, 3. Mr. Myers, did I do it right? Did I do it right? Kid, did you do it right? Kid, did you do it right? Kid, did you do it right? How do you check? What's 8 plus 15? 23, that's what I wanted. What's 6 minus 15? Negative 9, that's what I wanted. So did I do it right? All right, now we come to the most important part of this unit for me. What's better? I know both are fine, but every year my class gets mad that I taught one before the other one. Do you care? Of course not, because they're equally useful, right? You guys try this one. What's wrong with it? Nothing cancels out. But we have tools to make these change so they look the same, don't we? What can we do to this guy to make it look like this guy? If I multiply this guy by 2, what do I get? 2x minus 4y equals 14. Now, when I add them, will something eliminate? Great. We're not going to do that yet. Come over to this one. Anything the same? So that means I got to multiply one of them at least. But in this one, I got to multiply by both of them. What should I be trying to get to? If I multiply that by 2, I get negative 6. If I multiply that by 3, I get positive 6. So I would get 4x minus 6y equals what? 40. And 33x plus 6y equals negative 3. Then I could add to do my elimination. You guys do those two. Is everybody good? Nothing new, right? Soon as you see it on a graph, oh, it makes perfect sense. Is everybody good? Everybody good? Now I want to show you something a little weird in a second. I want to make sure everyone's okay here. Remember, this is all just algebra, right? There's no new skill here, but you got to be good at algebra to do this. How do you get good at algebra? The same way you get good at everything in the history of the world. You practice it. Go to the bathroom. The which? Which 8? This one? When I brought that 6 over, what happened to it? No, when it comes over there, it becomes negative. So 14 minus 6, right? Oh, that's a negative. Good call. Thank you, gentlemen. That should be negative 2 for y, which means our x will change. No, our x is still good. I forgot that guy was negative. Now, wait a moment. Let's pretend that you didn't have 30 people desperately trying to find your mistakes. Everybody understand? Let's pretend that I gave you this on a test and you did this. Would you ever have done that? I hope not, because on a test, when it counts, what should you have done as a last step? double checked. 3 minus 2 times 2 is 3 minus 4, correct? Is 3 minus 4 7? Or is it? No. So when you checked, you would have said, oh crap, that's wrong. And then you would have gone back and looked. Oh, negative right there. Stupid, stupid, stupid man. And now it works. Right? Okay. Now, I said I wanted to show you one other thing. Please notice. What do you notice about all three things we did? We always ended up with two of them that were opposites, yes? So we could add them together. Everyone agree? Okay, well, what if I gave you, and don't write this down, I just want to show you. In this one, I have no opposites, do I? So I could just subtract instead of trying to get opposites. Does everybody see that? 4 minus 4 is 0x, so they drop out. But if you're going to subtract, you got to be careful, because what does that negative do to that negative? So what would I have here? 4y. And what is 8 minus 8? 16. You got to be careful if you're going to subtract. All right? If you're bad with remembering this, you may want to take what you are dealing with and say, wait a minute, I'd like there to be two that are opposite signs. So you may want to multiply this by -1 and then just add. You follow me? Who makes that choice? You do, based on your comfort level with numbers. But the nice thing about this unit is if you do happen to screw up, it's so easy to find your error. Right? Okay. Just like yesterday, I do have a puzzle sheet if you want to have some fun. And I got 12 practice sheets. Or 12 practice questions. 12 sheets. This is really important. Tomorrow, ladies and gentle people, we will finish grade 10 math. Tomorrow we're going to finish it. Indeed. Tomorrow we'll finish it. That's Tuesday. Wednesday, we'll do our review of our last unit. Friday, we'll write our test on Unit 8. Now listen carefully, please. Listen, please. Listen, please. Listen, please. Thank you. Remember a couple of days ago we discussed about how the old calendar, what I've been planning my whole year on, had 2 extra class days on it. Those class days apparently did not exist. Those 2 extra class days were the days that I was going to use to review the year and do a cumulative on units 5, 6, and 8. Those 2 days now do not exist. Okay? Well, I mean, they're still there. Like Monday and Tuesday next week are happening. It's not like we canceled them. You don't wake up on the morning after Sunday and it's suddenly Wednesday. But it does mean I do not have the period to review stuff from the year. But that's no big deal because you have all the videos. You have your whole book right there. You have 2 cumulatives. So that I'm not too worried about that. What I am bothered by is the chance that you have not had to improve your grade on units 5, 6, and 8. So here is my proposal. And I cannot remember if I've already said this to you people. I get confuzzled because I have so many classes. My proposal to you is the exam week, which for you people, and as far as you're concerned with me, is Thursday, January 24th. You'll be writing your final exam in here in the morning. Any day of that week in the afternoon, you may come in and write a cumulative if you wish. Okay? Yes. So Monday through Thursday of next week, any day after lunch, you may come in and you may write a cumulative. I see your hand, Tabby. I'll get you in a second. You may come in and write a cumulative covering Units 5, functions, Unit 6, graphing, and Unit 8, systems. Tabby, go. Okay. I'm going to assume I already answered your question. Any other questions that have not been answered? I feel that those are pretty easy to follow instructions. So I'm going to cut a couple of questions off at the pass. Do you have to come in and write that cumulative? No. Would it be an intelligent thing if you're going to write that cumulative to write it on Thursday after you've already done your final? No, that would not be intelligent. However, it is still possible if you were just trying to improve your grades. But to have it to study from, it would be a good idea to take it beforehand. If you write it beforehand, you will want to know how you did. So, is writing it on Wednesday a good idea? No, because how will I mark it and be able to talk with you about it? So, if you actually care, what are the days you should consider writing your cumulative exam? Which afternoons? Monday or Tuesday. Now, one of those days, Monday through Thursday, you will have that numeracy exam for the government. Did I give you your date and time? No. I thought I did. No? All right. It will be on... I have to check because I have 4 classes and they're not all writing it on the same day. I believe